Namaste, and welcome back everyone to Paul Talks Statistics. I'm your host, Dr. Chinmoy Paul, bringing you the stories, science, and secrets of statistical techniques. Today we are diving into a very popular unsupervised learning algorithm in data science, K-means clustering.
And I'm Ria. Whether you're a student, researcher, or a data enthusiast, understanding K-means will help you explore your data like never before. So, let's begin. What is K-means clustering?
So what exactly is K-means? It's a clustering algorithm used to group similar data points together. Unlike classification, here we don't have labeled data. Instead, the algorithm tries to find natural groupings or clusters in the data.
Exactly. And the K in K-means stands for the number of clusters you want to divide your data into. For example, if you choose K equal to 3, the algorithm will find 3 clusters in your dataset.
How does K-means work? The working of K-means is quite intuitive. It follows a simple four-step process. Initialize, randomly pick K cluster centroids, assign each data point to the nearest cluster centroid, update, recalculate the centroids based on current cluster members, and repeat. Keep repeating the assignment and update steps until the centroids stop moving significantly.
Basically, it's trying to minimize the within cluster variance, meaning data points within the same cluster should be as close to each other as possible.
Where is K-means used? K-means is used across industries. For example, in marketing to segment customers based on buying habits, in biology to group gene expression patterns, in image compression to reduce the number of colors, and in finance to detect customer segments for credit risk analysis.
And it's also very popular in social media analytics, customer segmentation, and even astronomy.
Now, it's not all sunshine. K-means does have some challenges. It assumes that clusters are spherical and of similar size. It's sensitive to outliers, and choosing the right number of clusters, or K, isn't always easy.
To solve that, we often use the elbow method or silhouette score to find the optimal number of clusters.
Tools and implementation. In Python, you can use K-means from scikit-learn. In R, it's available in the stats package. Even in Jamovi, you can perform clustering with a user-friendly interface.
And you'll often visualize results using scatter plots, heat maps, or 2D projections using PCA.
Final thoughts. So friends, K-means clustering helps us find patterns in data, not by labels but by structure. It's fast, intuitive, and forms the backbone of many exploratory data analysis workflows.
Just remember, always pre-process your data, scale your variables, and try different values of K before finalizing your clusters.
We hope today's episode gave you a clear understanding of K-means clustering.
If you enjoyed it, please follow Pal Talk Statistics and share it with your fellow learners. Next time, we'll talk about hierarchical clustering, another way to group your data. Until then, take care and happy clustering.